Uh, Hello, everyone. I hope I'm audible to all of you. And my name is Sudeep. I am the CEO and founder for AI World Technologies, and we are based out of Bangalore. We mostly work on ML and AI applications, and embedded happens to be one of our core technology in which we have vested. So all of you would be aware that today we are going to do some hands-on for Raspberry Pi, right? And not just any other hands-on, but we'll be focusing mostly on image processing and machine learning applications that can be done on an embedded board. So before we proceed, guys, I would like to tell you that I want this session to be as interactive as possible. Okay, I want you people to shoot your questions at me, and likewise I'll also be asking you certain things every now and then. Let us make it more like a fun session. Okay, great. So let me quickly share my screen so that we can all begin with the session. So my screen is visible.
Yes, Sudhir. It is visible.
Great, great. So let us look at the agenda for the workshop. This workshop is divided into 3 days. So the first day of the workshop will be learning about Raspberry Pi. I mean, what it is, how to use it, and the next step is setting up an Raspberry Pi in case you don't own a monitor or additional sets of keyboards and a few other things. Plus, we'll also learn how to install the image processing library onto it. And once we are done through this, we also get Pi camera or even your normal USB webcams. And we will see how to capture an image through the Pi camera. And we'll see how we can convert this into various color space that's available. Okay. And in the second day, we'll go ahead with some advanced topics like edge detection, image filtering techniques, and enhancement techniques, let me tell, not image filtering. And we'll understand what a video is, okay? And subsequently, on the third day, we'll deep dive into advanced topics like machine learning on an embedded hardware and see how we can best utilize a small piece of hardware for our application, So let us just begin with what a Raspberry Pi is. Before that, how many of you have used Raspberry Pi? I mean, if you are shy to talk, you can even text, there is a chat option there. So I want to know how many of you have used Raspberry Pi before. So I'll just put up a poll question, okay? And you can answer there. Okay, guys, I have sent a poll question, and I would like you all to answer this so that it would make my understanding clear and how many of you are aware of it, and I can take the session more better to your understanding. Okay, great. So looks like at least um, 80% of our participants have not used it before. So we'll jump in right away from the basics itself. So coming to Raspberry Pi, it's a small electronics device, okay, which has an processor, RAM, and all your peripherals on board. So you can also call it as a mini computer, okay, instead of a microcontroller, because usually um, when you come to a microcontroller, it would be a processor which has all the RAMs, ROM, and other GPIOs clubbed together on a single chip. But in case of Raspberry Pi, it's like your computer motherboard, okay, wherein you have a processor, a RAM, a wireless module, Bluetooth module, and all this combined together to form a system. Okay, so the popularly used Raspberry Pi model are Raspberry Pi 3B and Pi 4. So in this workshop, we will be referring to these two models only. And you can also, I mean, you will find a lot of other Pi models like Pi 0, 0 Plus, etc. These are also really good and useful for, miniaturizing your application where you do not need a lot of processing power, but you just need some basic operations to be done. Okay, great, guys. That's a really great response from all of you. Okay, so if you see in this, you can see that there is a Raspberry Pi figure that is attached there. Okay, and you can see on, just let me take a pointer, give me a minute. Yeah, so here is where you can connect the Pi camera. Okay, and other parts are labeled. This is your processor. This is your processor, and other are onboard components like RAM, ROM, etc. And your micro SD card goes beneath this module. Okay, I'll try and show you a Raspberry Pi module during this workshop, physical one, so that you'll have a clear picture of it. So let's proceed to the next step. So once we have this Raspberry Pi hardware with us, there are a couple of requirements that is needed. Even if you want to set up a headless mode, you will need a 16 or 32 GB memory card. Recommended is 32 GB. Once you have this memory card, you will need to download the operating system for Raspberry Pi. Okay. So let me just quickly take you how to download, what to download, and how to burn it on an memory stick. Okay. Um, so I'll be sharing you my screen. Okay. So guys, if I click on if we click on this link, you will end up to this Raspberry Pi page where you can download your operating system. Okay. So here you can see there are a lot of different models, I mean versions of the OS available. So for beginners, I would recommend to go with the first one, that is Pi OS with desktop and recommended software, since it will give you most of the tools and libraries that are required for most of the processing pre-installed. Okay. And if you go to this OS Lite, this does not contain any GUI. It will only give you the command prompt or the cell, and you can do a lot of operation from this. Only the thing that is that you will not have is a GUI. Okay, this is useful when you have a heavy application to be processed, and since it has limited memory, even Raspberry Pi, you can optimize the use. So let's say you can just click on this download. Okay, once the download comes, you can just click on download. I have this file, so I'll be skipping the download. Okay, once it is downloaded, once the OS is downloaded, you need to use something like Rufus or Win32 disk imager to burn the ISO file onto the memory card. So let us look at how we do this. So to download Rufus, you can just go to your Google and type Rufus. You will get the first link. Okay, this is the Rufus uh, software. So you can just download it, the first link itself. Okay, I have this application, so I'll not be downloading it. Once it is downloaded, you can install it and you can open Rufus. So this is what Rufus will look like. Okay. Now, once you plug in a memory card onto this, it will automatically get the memory card that's there, and you can select the OS from here. So let's say I just downloaded this Ubuntu. I can open this as the ISO that I want to burn to the memory card. I'll select the device, click on start. Okay. And once you click on start, the status bar will show you the progress. So once you have successfully completed the burning process or writing the image to the memory card, the next step for us is to browse to the memory card, okay? And we will create a new file called SSH. So how you can do is, let's say this is my the memory card drive location. All I need to do is go here, new text file, select everything, type SSH, and if any warnings you get, you can press yes. So why we create this file is, by default the SSH, terminal mode or cell mode for the Raspberry Pi to be accessed over a network is disabled. So once you keep this file in the memory card on the top, you get access to the network access over the Raspberry Pi through your shell script. Okay. So once this is done, the next step is to take out the memory card from your computer, plug it to the Raspberry Pi, and turn it on. And also just remember, guys, in case it's a first boot, you will have to use an Ethernet cable. Okay, you will have to use an Ethernet cable to connect your Raspberry Pi to your router, because you'll not be able to configure the wireless network immediately. So once your Ethernet cable is connected, you need to download a software called Wireless Network Watcher. Okay. So what Wireless Network Watcher does is, it scans your network and tells you what devices are connected onto it. Let me just show you how this application looks like. So this is the Wireless Network Watcher. I can just rescan my network. Okay, and it will show all the devices that's connected to my network. So as you can see, my PC is connected to the network and it's shown here. Same way, once I plug in Raspberry Pi, you can see here it says Raspberry Pi Trading Limited, right? What you need to do is note this IP address. Guys, can you mute yourself? Thank you. So what you need from here in this application is this IP address. Do you see the 192.168.1.4? Yes, this IP address is what we'll be using to access the Raspberry Pi over our network. Okay. So moving on to the next step. You have connected your Raspberry Pi to the network. It's powered on. You have the wireless network archer and you have the IP address with you. Now, the question is, how do you access your SSH? Okay, so for that, we have a very simple application called Putty. Okay, so Putty can be downloaded from this link. The PPT would be available with you. Else, you can just note it from here. You can also type Putty in Google, Putty, and you can download the first link itself as per your operating system. So Putty is available for Linux and Windows. Okay, so once you get to the file, you can just download this and install Putty. So let me show you how the Putty application looks like. This is your Putty, and you will be entering that IP address. You see this IP address 192.168.1.4, right? So that you will be entering in the Putty to access the Raspberry Pi over SSH. Okay, so now we can click open. Just a minute, guys. Let me quickly fix the network for the Raspberry Pi. Sorry guys, I have just kept the Pi for reboot. Okay, while it's booting up, we'll see a couple of more things that is needed for your setup. So you will use the SSH for the initial few setup. Okay, meanwhile, we can go and download another application called Vnc Viewer. Okay, if you type in Google Vnc Viewer, you will get the first link that is available for you. Okay, so you can just click on the first link and download the Vnc Viewer from here. So once the file is downloaded, you can install it, and it's available for Windows, Mac, Linux, and all the possible operating system that's out there. So let me just show you how VNC looks like. So your VNC viewer will look something like this. Okay, and And once you have got that IP address, you can put it into the Vnc Viewer and you can start connecting to it. Okay. So we'll wait for the Raspberry Pi to pop up on the network. So the Raspberry Pi has popped up onto the network. So you can just go to putty 192.168.1.4. So it will give you some warning initially. You can click on accept. Okay. Your username is always Pi. Okay, note it down. Your username is always Pi. Password will be Raspberry. Raspberry. So once you have successfully logged in, you can see the Pi @ Raspberry Pi as a user and the current login. Okay, once you are at this page, let us look at a couple of setups that we need to do. So you can note this down. Your login is always Pi, okay, and your password will be always Raspberry. So the next step is you need to configure a couple of settings onto the Raspberry Pi before we can use them for other applications like camera or accessing it over a network or accessing it with the Vnc Viewer, enabling the GPIOs and all those. Okay. So for that, what we do is my screen is visible to all of you. Guys, you can see the putty screen, right?
Yes, sir.
Okay, great. Thank you. So what we'll type is we'll type in sudo raspi-config. Okay, this will open the configuration page for the Raspberry Pi. So you get a lot of options in here. So the first thing we'll go is go to interface option. Please remember, we'll go to interface option. You see the Pi camera there. So all you need to do is first go and select on the Pi camera. It will ask, would you like the camera interface to be enabled? You can just click yes and the camera interface will be enabled. Okay. Same way, we'll go to interfacing option and we will enable VNC. I have already enabled VNC, so I'll not be doing that. It's same way. You just have to click, and once it asks you, would you like to enable VNC server? You just press enter and it's enabled. Okay. And same way, if you are working with some external sensors or hardware, you can enable SPI, I2C serial ports and all those. Okay. So we'll be going back. If you go to advanced option, you can go to this network interface names. Okay, here you can use this option to connect to a wireless network. Mine is already connected, and so I'll not be changing it right now. I'll be showing it from the VNC how you can change your wireless networks and get rid of the network cable that you are on right now. Okay, so once we are done with this, the next step is to update your Raspberry Pi. Once you have installed it, you need to update the repositories and the installed application to latest available versions. So for that, guys, how many of you are aware of Ubuntu commands, or you have used Ubuntu? So I'll just be taking a poll again so that I get to know. Somebody has asked me whether it is a microprocessor or microcontroller. You can call it a handheld PC actually. It's a mini computer. So it has a microprocessor on it as well as all the RAM, ROM, everything. So when you say it's a microprocessor, it's only like the Intel chips i3, i5, i7, or the Broadcom processor that we spoke about, something like that comes under microprocessor category, okay? And when you see Tel as a microcontroller, it's basically a combination of your RAM, ROM, processor, everything onto a single chip. So Raspberry Pi falls into the category of a computer. Okay, so I'll just quickly create a new poll. So if you can quickly just answer this, I can tell you and explain you some Linux commands as well. Okay. We'll wait for another 20 seconds for other participants to complete. Okay, guys, that's a wonderful participants that I have. Awesome response. Okay, so most of you have used Ubuntu or Linux once or before, and that's really good because it's important for this session to understand a couple of things, because your Raspberry Pi runs a custom version of a Linux or Ubuntu. Okay, Debian. Let's not call it something else. It's a custom version of a Debian that is specifically built for your Raspberry Pi. So most of the command sets that you would use on a Linux or an Ubuntu on a computer system will work as it is on a Raspberry Pi. The only difference that is there is in the architecture of the CPU or the PC architecture. Your PC will usually have an x86 architecture. Okay, and while Raspberry Pi will fall under ARM architecture. Okay, so whenever you install some libraries or install something that depends on hardware level acceleration, you will always see the downloaded file comes as it will have ARM HF extension or some kind of naming attached to those library files. Okay. Great, guys. So let me again share my screen with you. Okay, guys. So I was telling you about the Linux command. Most of you have used it. So you know why we use sudo? You can even text me if you are not sure. You will speak out on that.
Super user.
Yes, for super users. So what does super user do? I mean, why do you want a super user access?
Get the admin profile, like to make changes to the system.
Okay, yes, that's absolutely correct. To make changes to the system, which are restricted to your normal user or current user, you need to switch to super user. Yes, to get complete access of the OS actually, we won't say the whole board, it's to get complete access to the OS. Okay, so sudo is a command used to elevate your system to a super user mode. Okay, like in Windows, when you right click and say run as administrator, dialog box pops up, right? Saying user account control, do you want to allow this to run in administrator mode? So consider that this sudo or a super user as an administrator mode for Windows. Okay, so hope it is relatable. So the next thing, you install Linux on your system or on any embedded boards. Apart from Raspberry Pi, there are a lot of other boards that run on a similar architecture, like your NVIDIA Jetson or Udo Quad, Udo x86, etc. Once you have downloaded and installed an OS, keep in mind that you should always update to the latest repositories and installed files upgrade. Okay, so what we'll do is we'll put sudo apt get update. Okay, so we'll be using the command sudo apt get update to update the repositories first. Okay, uh, so this takes a couple of minutes depending on your internet connection to update the repositories that comes pre-installed. So you know what are repositories in an Ubuntu system? Anyone? Yeah, you see this HTTP archive.raspberry Pi, some links are there, right? Which are getting updated with some KBF file each downloaded. What do you think are those? What are these repositories? Why are they important? And what do they mainly help you in? So these repositories are nothing, but it contains all the link to the downloadable libraries and applications. Okay, that's available for your system. So when you say apt get install, let's say uh, some application, apt get install Chrome only. So it will look for that Chrome in one of these repository and download it from there and then install it to your system. Okay, so that is the application of it. And when you did update, it updated the repositories. That is, it refreshed the repository links. Okay. So once it is done, the next step will be sudo apt get upgrade. So this will now upgrade all the applications that installed here. I'll not be doing this right now because it will take some time. So once you get what are the libraries and files that are to be upgraded, you can just press yes. It will take approximately 15 to 20 minutes to complete this process, depending on your internet connection again. And once it happens, you are ready to go ahead with your Raspberry Pi. Okay. So just give me a moment. Okay, so now we'll move on to the Vnc Viewer. Okay, guys. So what Vnc Viewer will give you is an access to the Raspberry Pi GUI. This is what we will see once you connect your monitor to a Raspberry Pi. Okay, so you can see the VNC server is installed here, which is actually allowing us to use this VNC Viewer. Here is your Wi-Fi. You can just click on it and then select one of the available Wi-Fis and connect to it. Once you are on a Wi-Fi network, you can easily disconnect your LAN cable and then switch on to the new IP address that is available for you. Okay, so let us look at installing a couple of libraries before we proceed to the next set of experiments. Okay, so before we proceed to it, we need a couple of libraries to be installed to the system. One of them is Opencv. So are you aware of Opencv? Have you used it anywhere, or you heard it anywhere? It's Opencv. No. So it's an open source. Yes, it's used for computer vision applications. Yes, very good. Looks like some of you have heard or used it before. Great. So it is used for computer vision applications. Okay, it's an open source library that is available to you. So for this entire session, we will be using Python, okay, as our coding language. I hope all of you are familiar with Python. Okay, so all of you are familiar with Python. That would be great. So guys, if you don't know Python, you can just quickly text me or ping me on the chat so that I'll explain you a couple of things, differences, what are the different Python version available. Okay, so I'll assume that all of us are aware of Python or at least have used it once. So you will be using Python. No? Okay, let me quickly brief you on Python. Okay, Python is a scripting language. Okay, I'll not go into the theory of it. I'll just tell you how to use it and how you will proceed with it. So your Raspberry Pi already comes installed with Python and Python version 3. Okay, we will be using Python version 3 as Python version 2 is already obsolete. Just mute yourself. Okay, sorry for the disturbance. So we'll be using Python version 3 for the programming. Okay, and Python is a very simple language. If I talk in layman terms, your input to take an input, you can just write input. If you want to print something on the screen, you have print statement, and syntaxes are available. I'll also show a couple of them when we go through or as we progress through the workshop. Okay, and to import any libraries, it's as simple as import like let's say CV2 or import TensorFlow or something similar. Okay, so once we do that, we have if we have Python version 2 and version 3, you need to use pip3. Okay, for installing libraries, we'll be using pip3. So pip3 install Opencv-Python. Okay, so this is the command to install Opencv library to your Raspberry Pi. So once you do this, it will install the libraries that is required. For me, it's already installed, so it won't be updating or doing any or taking any actions. Okay. So guys, now we'll start with the applications or the experiments for today. So the first one is reading an image, okay, whether it is from a camera or whether it is from a local file or local folder or whatever it is. Okay, so let us just have a quick look at it. So I have a question for all of you. What is an image? Any one of you can unmute yourself and answer if you know it. What is an image? So when I say this, it's a combination of multiple pixels. Yes, absolutely correct. Image is a combination of pixels. Yes, moment captured. That's for human being. But when I say what's an image in terms of a computer system, we will have to, yes, it's a matrix, correct? So image is nothing but arrangement of these pixels in a 2D matrix. Okay. So yes, RGB is a type of image, red, green, and blue. When you have a combination of all these colors, but you have different color space also. So what is this pixel now? All of you told me correct answer that it's a matrix, it's pixel, it's combination of RGB. But what are these pixels? Now, I wouldn't expect answers like it's a basic building block of an image. So I'm just asking you in layman term, what is an image? You told it's pixels. Pixels are color dots. Yes, to some extent it's correct. So how does a computer understand a pixel? Pixel is nothing but numbers for a computer, okay? So this pixel ranges from 0 to 255. You know why 0 to 255? Why does a pixel only range from 0 to 255? 8-bit. Absolutely correct. Because your sensor, the camera sensor or the CMOS sensors are all 8-bit, and 10 to the power 8 if you do, it's 256. Sorry, 2 to the power 8. Sorry, 2 to the power 8 if you do, it's 256. So it is 0 to 255. Okay, so when we say a pixel is 0, what does it mean? And when you say a pixel value is 255, let us not consider a RGB image in this case. Consider a black and white image or grayscale image. To be more precise, let us consider a grayscale image, which has essentially the shades of white and black only. When we say the pixel value is 0, what does it mean? When you say the pixel value is 255, what does it mean? Take a guess. Yes, absolutely correct. 0 is black and 255 is your white. Okay. So the range between black to white, you will get grayscale or gray shade also in between, right? So that's why it's called grayscale. So when you come to an RGB image, now what it changed? 0 still remains black. Okay, in case of RGB also. But in case of RGB, yes, a 3D matrix, absolutely correct. It's a 3D matrix. So in which you get three different bins, color bins, okay? That is red, green, and blue. Overlap of these three color bins will produce these images that you can see green or that apple or the cat or for example, even that baby. So it's a combination of three layers of matrices, that is R, G, and B in various intensity. Okay. So by various intensity, I mean 0 to 255 scale for each of these pixels corresponding to the RGB matrix. Okay. So that's how an image is formed. Uh, it's pretty simple, right? We just take a camera and point and shoot and we get a clear image. But if you understand the principle behind it, it's even more amazing. So basically, when you take an image, it's nothing but the reflection of that object which is getting captured, okay, by your camera. That is an image. So when the object reflects, when it has a light source on it, it gets captured to your camera, and your camera processes it into a digital signal. Okay, basically whatever you see with your eyes, everything is mostly an analog feed, but when you see an image, it's a digital signal. It's a digital feed because of lack of computational power and sufficient hardware. An image cannot be an analog signal like for your eyes it is. So without further ado, let's have a look at the first program of today. Okay. So guys, even in case you don't have a Raspberry Pi, if you want to try this program, you can try it on your systems also. And for that, you will just need Python 3 installed and Opencv library. That's it. We'll keep it as simple as possible. So the first uh, application of the day is reading an image using Opencv library. Okay. So what we do is first we import Opencv. To import Opencv, you just need to type in import cv2. So this will import the computer vision library to your program, which you have just installed. Okay, the next step you can see is cam equals to. So the next step you can see is the cam. This is a variable we created. We are calling the CV2 library imRead function. Okay. This imRead function is used to read an image, and we are specifying the path location. So I have currently modified whatever is the program, whatever programs are mentioned in the PPT, so that you can even run it on your computer. So this is a location on a computer. Okay, while running, I'll demo it on the Pi also, how it comes. Now, in next step, whatever image we read, okay, we are again saving it back to a folder. So what we do is we use a command called cv2.imwrite. This is used to save an image. Again, to view the image, we use an Opencv call imshow. Okay, when you do cv2.imshow, this is a window name, red image. Okay, and cam is the variable that you initially created where you have stored the image matrix. Now, cv2.wait key, what it does is it waits, it keeps the image window open until some key is pressed by the user. Okay, so let us just look at how it runs. So all we need to do is to, okay, let me first show you the code. So this is the code that we have for the Raspberry Pi, and this is your location on a Ubuntu system. Okay, this is a path on your Ubuntu system, and we have an image called test.jpg, which is available on a folder. So what we'll do is we will read the image, we'll write it back to the folder, and we'll also display it and then close. Okay, so here is the test image. Now let us just run the application and have a look at it. So you will be using Python 3. So this is how you run an application. Python 3 space application, your file name .py. So you can see it displayed this image which is there, right? So it won't close until I give any input from my keyboard. So the moment I press escape or spacebar or any such key, it will close and end that application. Okay. So if you see there, this record.jpg was not there initially, right? But since we have used imwrite, it has recorded the same image and renamed it as record.jpg. Okay. So this is a very simple application using Opencv, wherein you can read some image from your files and folders, and you can store it or rename it or do some processing and again save it back. So guys, I hope this is a simple experiment and it's clear. I think even without the that knowledge of Python, I hope you are able to grasp this one. So let me just quickly take a poll from all of you. So if you can quickly answer this poll, we'll go ahead with the next experiments, wherein we'll see how to change the color domains. We'll wait for another 20 seconds to close the poll. Okay, great. Awesome, guys. Brilliant candidates. Most of you have grasped it till here, and that's great. So let us look at the other color space or color conversions that available for us. Okay. So let me quickly share my screen and we'll proceed to the next topics. So before I proceed to the next slide, I just want to check with you how many other color spaces are available there. Like one of you had mentioned RGB, right? A while ago we spoke about grayscale. Do you know about any other color scales that is available or that is known to you? BGR and RGB is essentially same. HSV, great. HSB, yes. It's HSV and HSI, not B. Any other? You know, in printing press, they use a particular color space. If you read a newspaper, at the bottom you would have seen 4 colors and cross hair mark also. It's RGBD, that is for depth. If you are using something like Microsoft Kinect or 3D cameras, you will get the depth attributes to it. So it's called RGBD. Yes, CYMK. CYMK is a color space that is widely used in your printing. Okay, printing in the sense your press and all those. So we got to know that there are HSV, HSI, CYMK, RGBD. But why do you need this so many, color space? It's already simple that we see these objects as it is. Why should we convert to all this color space? What's the necessity for it? Anyone? What's the necessity to get accuracy? Can you be more precise? What accuracy? Okay, let me just give you a simple example. It's easy for a human to differentiate between objects because we view objects as a 3D, right? And if you use a 2D camera, the computer to differentiate between objects, it's difficult. Take a very simple example that you have a green background and one square photo frame is hung on it. Now, how would you determine or how would you find out the location of this square frame on the green wall? Or how would you determine the shape by shape, I mean circle, rectangle, square, whatever? How would you come to this kind of conclusion using computer vision? Or how would your computer come to these conclusions? Because when it sees it, all sees is numbers, and all it compares is different numbers. So the green color that you saw, if you take a leaf picture, it's green, right? We know it's a uniform color when we see it through our eyes. But if you take a picture of it, Okay, let's just say this is a bottle here, right? So it is in green color, but when you take an image, it captures how much light has actually been reflected by that bottle. So you get a little different shades or different brightness from each of the part. So this makes the computer, first of all, difficult to understand or difficult to even comprehend that this green pixel and this green pixel is same or similar. Okay. So to make it easier for the computer to understand that yes, or to do some kind of pre-processing to obtain your reason of interest or application of interest, we use this color spaces as pre-processing. So let us look at the slide further. So you see this color image to grayscale image conversion. We'll just look at the maths behind it, how it works. Anyone knows how a color image can be converted to a grayscale? Guys, any one of you who knows how a color scale image is converted to a grayscale? There is a formula for it. We all know that color includes RGB, right? Three matrix bins that is combined together to form this image that you see on your left screen. So how is it converted to a grayscale image? Okay, let us look at the formula. So what you do is you take the sum of all the three pixels at a particular point, okay? At a particular point. Let's say uh, no, we'll not be changing the values to 0. What you will be doing is you will be adding the bins, pixel bins, this 3D matrix what you had, no? So the first element for all of RGB, you will be adding them up and taking average. That will give us grayscale. The other method is to use this formula here. Okay, that is 0.299 into red pixel and 0.578 into green pixel plus 0.114 into blue pixel will give you again a grayscale image conversion for your image. So you can see in this example where you have method 1 and method 2 both used for conversions of an image. Okay, so eventually you will end up with a similar results. Both are just two different methods to do it, where taking average is the simplest one. So basically you are converting a 3D matrix to a 1D matrix, okay? Or I should say 2D matrix. So let us have a look at the program for it, okay? So when you are using Opencv library, it's very simple. It's really simple for conversions. You need not bother about any of these formulas, but definitely you need to know these formulas for your future references, okay? Now, the next color space, okay, before we jump to the program, let us look at one more color space. Grayscale is different and binary is different. So can someone tell me what is a binary color space? And you would have seen it somewhere. Almost all of you would have seen it somewhere. Can you tell me where you have seen the use of binary image and what is a binary image? Zeros and one, absolutely correct. So either it is 0 or 255, right? In our term. in our image term, it is either 0 or 255, only two colors, either white or black. So where have you seen this? It's a very common application. Anyone? Take a guess. It's used in medical field. Absolutely correct. X-ray. Converting photos to sketch. I'm not sure. You can even use grayscale for it. It's an X-ray. Absolutely correct answer. So all of you would have at least visited the doctor once for X-ray, right? So when you see the film, it's binary image, black and white. It's not grayscale or any other color space. So even does it? I mean, two number color space is also useful, and it has an application in medical field. So not just X-ray, but it can be also used for various other medical applications wherein you are looking at the cells or something similar. Okay. So let us proceed further. And let us also look at the Hsv color space. So we were discussing something earlier, right? Why we need the Hsv color space and similar things. So when I gave you an example that how do you differentiate two different greens are of a similar type or of a same object. So I'll not scare you with this formula. We'll try and avoid it. I'll just tell you what happens and how it works. Okay. So what we do is we select a range, okay, of maximum and minimum that it has to club this particular range of pixel as a similar pixel or a same pixel. Okay. So earlier I showed you one bottle, right? You can still see it. So when the computer will see it, wherever the light has fallen maximum will look bright green to it, whereas the portions where the light has not covered much or it was dark will come as dark green. So you can set a particular threshold or a range and then use it to merge all similar pixel into one bin. Okay. So you can use this Hsv to basically for pre-processings wherein you need to group a similar color range or pixel range for your applications. So let us have a look at the application program here. So again, it's a very simple using Opencv. You can actually do wonders in a couple of lines itself instead of you having to type this big formula and then calculating the value for hue, saturation, and value. Okay, and your let me quickly explain you this formula also, just in case. So we are creating three different RGB bins out of the existing pixel values. Okay, so for each red pixel intensity, that is, let's say if R for that pixel point is 80, R dash will be 80 by 255, G dash will be similarly for that range. Okay. Now, once we have calculated the RGB for it, we need to calculate C max and C min for those points. So what we do is we take first maximum of this R dash, G dash, and B dash store it to Cmax, whichever is the greatest. Okay, same way, we also find the minimum out of those and we will store it to Cmin. So next step is we'll calculate the delta change or the difference between the minimum and maximum and store it to delta. Okay, the next is you need to calculate the hue, saturation and value for that particular pixel. So how you do it is you will use this particular you will be using this particular formula that's given for the hue. Total is 180 degrees. So what we do is we take first quarter, that is 60 into your G dash minus B dash and divide by the max. Okay. And similarly, the next point will be for the blue minus red and red minus green. We subtract each of these pixels from each other and we then get the calculated values and substitute it for the hue. Same way for saturation, also we get a matrix and we'll use this formula to use in first case, okay? We are substituting Cmax directly as 0. And in the second case, we can't have Cmax equals to 0 since it will tend to infinity. So that is the explanation behind this Hsv color space. Okay. Now, same way CYMK I have avoided in this, but if you want me to share some content on CYMK, I'll do that also. Just give me a minute. So let me quickly share my screen for the conversion table. This can be found online also, guys. Okay. So I hope my screen is visible. It's quite similar to the Hsv calculation that we did just now, wherein we again take 3 different bins and compute it, wherein your K, okay, K is for the black color, is nothing but 1 minus the value that you get out of the max of RGB. So the maximum value that you can get for R dash, G dash or B dash is 1 only. Okay, the same way for cyan color, you have the formula available here. If you want, you can note this down. And when it comes to Opencv conversion, it's a one-line call. But it's important that all of us understand how the color conversions are working in the background. Okay, so just to give you an idea on how it works. So if you take a RGB image where the first pixel value of red was 255, we'll keep this as 0 and 0. So it's a red pixel. You can just convert and see. Let me just reload it. Okay, meanwhile it reloads. We'll come to this again. Let us proceed to the program. Okay, let us have a look at the program. So again, it's similar. Opencv, to import the CV or Opencv, you can just type import Opencv. Again, we are creating a variable and reading the file that's on your system. Okay, and we are first converting the file into grayscale. So again, the gray that you see here is a variable name. It's not a function. It's a variable name. Let me use the pointer so that I can explain better. So this gray is a variable name. We use a Opencv2 command called cvt color. Okay, and we pass this original image cam to it, and then we'll use a call function called color conversion bgr to gray. Okay, and this is one very important thing that you should know. Opencv will read your colors not as RGB but BGR. Okay, so in case if you ever have a pixel level operation, this which bin will come first is important. So always remember, Opencv reads it as BGR in case of Python. Okay, so it's a pretty simple, straightforward. CV2 color underscore BGR2 gray will convert the original image into gray and store it to a variable called gray. Same way, to convert that image into HSV, 1 minute. We will be using Opencv command again, cvt color, and we will be passing the original image file, that is the cam. Okay, and we'll call a function called bgr to hsv. Okay, so the cam original file is in bgr format and we are converting it to hsv. Same way, we'll create two different windows, one for the hsv image and one for the gray image, and we'll display both on our systems. Okay, so if you want, you can replicate this program as it is on your computer also. All you need is a Python application, Python 3 and Opencv to be installed. So let us jump to our Vnc Viewer quickly and have a look at the program. Okay, so this is the program that's here, and this is the image path. Okay, now guys, in case I want to save the HSV image, what do I have to add here and where? Can someone type it in the chat window? In case I have to save the HSV image, what will be the syntax? What modifications should I do to this code in case I need to save the HSV image to my system? I am right. Yes. Can you write the full syntax? It's important. Just in case you need help, I can take you to the previous example also. I want to save the HSV. Okay. Please remember, I want to save the HSV image. So you can just quickly write the syntax onto the chat window. Yes, correct. img save may not work. So Jayasurya, whatever you have written is correct. Can you modify your syntax for this particular program? You are absolutely correct. can you modify your syntax for this particular program? I mean, what variable name will you add there? I don't need the folder location. What variable name will you keep there? cv2.im, right? Folder location, comma, variable name. What is the variable name? Hsv means great. So if you want to save, that is what you will be using. Okay. So great, guys. Looks like it's amazing. So let us jump into this example first. So again, to run the program, we'll type in Python 3 and the program name. Okay, we'll just press enter, and you can see this is in Hsv. This is your original grayscale. This is your Hsv. So what is the key difference that you find in this? Let us have a look at the original image as well. Okay, so this is gray conversion. Let us make small modification to the program. Okay, let us have a look at this. So let us get rid of the grayscale. So what is the inference that you can get when you compare the Hsv and the original image? Black is converted to green. Not really. So that is when you are observing the grayscale and the Hsv. Now you have your original image as well as the Hsv converted. So you remember the that problem statement that I was telling you a while ago, right? If a frame is hung on a green wall, 3D is converted to green. So yes, human face is differentiated. Absolutely. I need similar answers. It is also that the background is separated, right? And you can also say that all the text, they have a similar color, or they have a specific highlights to them, making it easier to attach or extract your ROI. So next time when you just want to pull out the information out of it, like let's say the human face, which is an important reason of interest, you want to draw a bounding box around it. You can just call for those pixels, select those particular pixels, map it, draw a bounding box or outline around it, right? So there is where your Hsv is very useful. So Guys, any doubt that you have on this so far? Let me quickly open another poll where I can take some feedbacks from you. So if you can quickly answer this, we'll move into the next stage. We'll wait for another 20 seconds for rest of the uh, team to complete. Okay, guys, great. So looks like so far you have understood um, the image conversions. So let us try the same applications on a different image and see what will be the result. I mean, right now you have seen most of it on a same image, right? So let us just quickly download another image. So let us quickly download one of these images. Okay, let us not take an image of big size. Okay, let us look at this image, okay? So here is our download.jpeg. So this is your grayscale image converted of the original image. Let us just close it and jump to the HSV and the originals, because I think that is where we are interested, right? So even in this case, if you observe, you get a clear outline or the reason of interest, that is the dog face. It is clearly segregated from the background, right? So not only for human, but if you want me to try the same application for some other objects or for a cluttered environment, we can do that also and see how the result comes. Okay, now guys, you are seeing that we have a problem here, right? The entire image is not being displayed. That's because the pixel size on the screen is not matching, right? I mean, the image pixel is greater than the display size. So what do we do for that? Any guess? How do we reduce the maximizing the screen won't work? Let me just show you. Even if I maximize the screen, this is how you get it. Yes, correct. We can resize the image. Okay. So we can resize the image. So how do we resize the image? In Opencv itself, we have a resizing formula. Okay, that's called a resize. So let me first move to windowed mode since it looks ugly. Okay, and let's see how to resize it. So let us come here. We'll type in gray equals to cv2 dot resize. Okay, and we will feed in the gray that we are getting from the above image. Okay, and we will set the pixels as, let's say, 0,0 as a size, and we will use two functions called x dimension 0.1 and y pixels. So since we are over the network, the typing is a little slow from the Raspberry Pi to my computer. Okay, so please bear with me. We'll complete this. Okay, great. Similarly, let's try for HSV also. HSV image, comma 0,0, comma fx equals to 0.1, fy equals to 0.1, Control S. Now let us see. So what do you see in this? We have successfully resized the image. Correct, but the way I have written the code, do you think it is the optimized way of writing it? Yes, no, what would be the optimized way? You can actually resize all the three images with just one line addition to it. Can anyone take a guess? Yes, even this command would work, cv2 resize image, wherein you feed in custom pixel size. But doing this has a risk. You need to know the image height and width, okay, in order to resize it properly. Otherwise, you might end up with pixelated image. So, guys, instead of me adding these statements twice, I could have just added it once and all our images would have a similar size. Just a moment, let me connect back to the Raspberry Pi. Okay. So if I change it to 0.5, what will it do? Any idea? If I make it 0.5, what will be the impact? Also, let me show you what I meant. So what we'll do is we'll comment of this line. Okay. Hash is used for commenting. And let me paste this here. Rename it as cam. Put it as cam. Save. Let us run and check again. What's the result? So now you can observe all the three images are automatically resized, right? And that's because all we had to do was to resize the original image. So right now this is at 50%. Okay, this is at 50% of your original size, and the image is not pixelated also because you are multiplying the height and the width by 0.5 each. So this is a nice trick to get your image resized without losing or without pixelating them. Okay. Similarly, when it comes to Opencv, you don't need this function also in case you have to work on only grayscale images. All you can do is while reading the image itself, you can add here comma 0. Okay. What this does is it takes the image directly as a grayscale. That essentially reduces your one line of code that is to convert it to grayscale. But you will lose the original image in this progress. Okay. So guys, we saw how these images are resized, whether you want to enlarge them or you want to shrink them. But when it comes to the maths, how is it actually shrinked? Let me use the annotate tool. Let's say this was your image. Okay. Matrix wherein you have a 4x4 and each of these are 1 pixel. Okay. Now I want to reduce this image by half. How would you do that? You can type it in if you have any idea. So guys, cropping the image is not the solution because you will lose the information, right? So what we do is the simplest method I'll tell you. Take this 4 pixels, okay? So add them and put the value in the new matrix, which is 2 cross 2. So take average of all this and add it here. Same way, take average of next 4 sets and you can add it here. And the same way, the average of these 4 will go to this pixel. This way you will have an image that is reduced by 50%. Okay, this is clear. Yes, it's like max pooling, correct. So essentially max pooling also is used for us to reduce the number of features that are to be passed, right? Or dimensionality reduction, basically. So this is how you can resize an image. Now this is for shrinking an image. How would you zoom an image? Imagine the same image is there. How would you zoom it now? Shrinking was something like max pooling, pretty easy. We are done and dusted. How do you zoom the image now? There are various methods, okay? What I told you is the simplest of all. But when it comes to zooming, how do you zoom this image now? I want a 2x zoom. Yeah, yes, convert one matrix to 4. Correct. So what we'll do is we'll take this, replicate it 4 times. 1, 2, 3, 4. Same way we'll take this, replicate it 4 times. 1, 2, 3, and 4. Okay. Again, this will come here. 1, 2, 3, 4. So I don't want to keep on drawing the dots, guys. Looks like you have understood the idea. It's clear, right? On how you zoom and shrink on a basic level. Great, great, great. So guys, we have come to end for the session today. We were as planned. So for tomorrow's session, let me just quickly brief you what's there waiting for you. So we'll look into some advanced applications, okay, wherein we will read footage from the camera of the Raspberry Pi, and or you replicate the same pixel values. Let's say if the pixel value there was 5, you just need to put 5 4 times, and you will need to create another matrix of twice its size. So 4 times zoom is to 16 is 16 times, right? For this, you will have to use something called as linear stretch. If you use the method which I just told you, you would end up with a very pixelated image. So guys, if you have any other questions, please shoot them right away. I'll clear if you have any doubts or anything more that you would like to know on these topics. We'll clear it off right now, and then I'll brief you what's there for tomorrow. So yes, it will be shared with you. Any other questions that you have on the use of any of the softwares that I showed, like Vnc, Putty, or Wireless Network Watcher, or even setting up your Raspberry Pi? If you have any doubts, you can please ask right now, and we will get it cleared. Okay, so you can unmute your mics and start firing your questions if you have. I'll try my best to clear them. So I'm not sure about RPi imager, and could you rephrase your question for setting an image? Oh, you mean writing the image to the memory card? Yes, you can use RPi imager. Okay, that's even convenient tool. It will directly download the Raspberry Pi image and install it for you. No need to download additional softwares or additional OS. Absolutely, you can go ahead and download RPi imager also. Anything else that you have, guys? Anything related to Opencv or color conversions or real-time applications of whatever we saw today? I mean, no matter how small these experiments were, they have their real-world applications. Okay, looks like the session went. All of you have understood, and there is no doubt the recordings will be shared to you. Please check with your coordinators. And yes, for tomorrow we have something called is image processing effect. Based on the Raspberry Pi model, the RAM size and the processing power would differ. Okay, so essentially, higher the RAM, better the processing capability. I mean, better the loading capabilities it will have. So if you use a Raspberry Pi with 4 GB RAM, which is Raspberry Pi 4, and one with 1 GB RAM, you will obviously observe a significant difference when you are performing complex calculations. The applications which I showed you right now are pretty straightforward, but when we move to next level of applications which are in your tomorrow and day after tomorrow's workshop, you can observe a significant lag. Okay, guys, so for tomorrow we have edge detection. That is nothing but detecting the boundaries from an image for an object. So we'll see how it is performed and what are the various edge detection softwares, I mean techniques available. Same way, we'll also look at some image enhancement techniques, okay? How to brighten a dark image, or how to do some color correction for an image. If you have used Photoshop, you would have come across something called gamma correction, okay? I'll not be explaining it right now, we'll save it for tomorrow. So in case if any of you have used Photoshop, we can go and check what are the different implications of that gamma correction when you do perform it on your image. Okay, guys, with this, we will end this session for the day. Thank you everyone for attending the session, and it was wonderful to see all of you really actively responding to my questions and polls. Thank you very much, and have a great day.
Yeah, thank you, Sudeep. Thanks for giving such a wonderful session, and thank you, participants. Tomorrow.
Thank you, guys.